Hello friends, now in this video we are going to learn about the term symbols. Generally a term symbol indicates about the electronic state of an atom, briefing about the total orbital angular momentum as well as total angular momentum. Now let us see how we indicate the term symbols for the elements. Generally a basic term symbol is represented as this 2s plus 1 L J, whereas S represents spin multiplicity, L total orbital angular momentum and J total angular momentum. Now let us see few examples. Let us try to understand with few examples like helium, oxygen and chlorine, and correspondingly these are the term symbols for these elements. Now let us see step by step developments to arrive to these term symbols. Now starting with the helium, we know that helium atomic number is 2 and it is represented with He. Now for this the configuration is 1s2. Now I am representing in the orbital configuration, so with 2 electrons in the same orbital with opposite spins. Now here let us try to give the term symbol step by step. First giving the 2s plus 1 value. In such case we have to indicate first s value. The s value, generally the spin multiplicity values are plus half as well as minus half. Now as 2 electrons are present in the same orbital, so one electron possesses plus half and the other electron possesses minus half, so both will get cancelled, therefore s value will be equals to 0. Now correspondingly the 2s plus 1 value will be 2 into 0 plus 1, that will be equals to 1. Now we have got the first part of the basic term symbol, the s value 2s plus 1. Now moving on to the L. So generally angular momentum values, so L value for the s orbital will be equals to 0. Now let us see here for L values, like 0 corresponds to S, 1 corresponds to P, 2 corresponds to D. Likewise, so I am showing all the corresponding values. Now if you see here, the 6th value is I, 7th value is K. J is missing as already J is assigned for the total angular momentum. Now generally the angular momentum value for a s orbital is 0, so corresponding to 0 we will get S. So as the value is 0, it is represented with S. And also remember here all the S, P, D, F, G, H, I and K and so on all are represented with the capital letters. Now moving on to the J value. So J value is dependent on L and S values. If the orbital is half or more than half fill, we have to go for L plus L value, L plus S value, and if it is less than half, then we have to switch over to L minus S value. Now if we see here, this orbital is completely filled, that is more than half fill, so we switch on to L plus S value. So the L plus S values, so L value we already seen here as 0 and S value also as 0, so total equals to 0. Now overall term symbol will be as this. So 2s plus 1 value is 1 and corresponding to 0 the L value is S and L plus S value, that is J value, is 0. So this is how we get the term symbol for helium. Next for oxygen. So we know that oxygen atomic number is 8. Now here we have to consider only the outer electronic configuration where the last electron enters into the orbital. So in this case we know that 2s2 2p4, so our point of concentration is at p4. So this is how the orbital configuration looks like. And now going for the S value, so spin multiplicity values for the 2 electrons within the same orbital can be assigned as plus half and minus half, and rest of the 2 electrons in the 2 different orbitals plus half and plus half. So totally this plus half and minus half gets cancelled, left over are plus half and plus 1 plus half, that will be equals to 1. Now therefore 2s plus 1 value will be 3. Now coming to the L value. Now look over here. For the angular momentum values for the p orbital will be +1, 0 and -1 for this orbital. Px orbital, py orbital and pz orbital. Px orbital is +1, py 0, pz -1. As 2 electrons are accommodated in this px orbital, therefore we can calculate it as 2 into +1 plus 1 into 0 plus 1 into -1. So overall it will be equals to 2 plus 0 minus 1, that is equals to 1. So now we have got the L value as 1. Now corresponding to the 1, the value is corresponding to the value 1, we have the symbol as P, capital P. Now looking over to the J value. So as this orbital is more than half filled, so the case where it is more than half filled, we have to operate L plus S value. So L plus S value, now L value we have got it as 1, and S value also we have got it as 1. So both putting together we will get it as 2. Now check out here. For oxygen, the S value, 2s plus 1 value we have got it as 3, and L value corresponding to 1 is P, and J value we have got it as 2. So this is how we represent the term symbol for oxygen. Likewise, pause the video and try out for chlorine and check out for the answer. So here how we can arrive to the term symbol of chlorine. Chlorine, its outer electron configuration is 3s2 3p5, or point of concentration is p5. So here the orbital configuration, this is how the electrons are filled in. So now calculating for the S value, here plus half minus half for these 2 electrons. Similar case is applied for the rest of the electrons. So overall the value, cancelling plus half and minus half, left out is half. So applying 2s plus 1 value for this, we will get it as 2. Next, going for the L value. Now we know that for p orbital we have px orbital +1, py orbital 0 and pz orbital -1. So there are 2 electrons in +1 and 2 electrons in 0, 1 electron is -1. Summing up, it will be equals to 1. Here also 1 corresponds to P. Now as this orbital is more than half filled, we have to operate L plus S. Now operating L plus S, we will get it as 3/2. So now here we can check it. The term symbol value for chlorine is 2p3/2. And in the coming videos we'll come across the very tricky questions on the term symbols as well molecular term symbols. Thank you.